This is Unit 12, Stoichiometry, Part 1 Notes. By the end of this unit, you should be able to perform stoichiometric calculations to determine mass relationships between reactants and products through the mole ratio, mole-to-mole conversions, mole-to-mass conversions, and mass-to-mass conversions. Stoichiometry are mathematical conversions between amounts of substances in a balanced chemical reaction to determine the mass of each substance based on either product production or how much reagent or reaction was consumed in the beginning of the reaction. We can also calculate or determine which reagent or reactant limits the amount of your product that is produced and calculate the percent yield of the reaction. These two concepts will be in Part 2, so Unit 12, Part 2 notes. What we're going to be learning about today is understanding and being able to calculate the mass relationships between all the substances in a balanced chemical reaction. So to perform stoichiometric calculations, they're all based on what's called the mole ratio between the substances in a balanced chemical reaction. This is a conversion factor derived from the coefficients of a balanced chemical reaction. So if we're unable to balance chemical reactions, then all of these calculations will be incorrect. So the first step for any calculation that we have to do, if we're given a chemical reaction, we have to double check to make sure it's balanced. So then the coefficients of that balanced chemical reaction will represent the molar amounts within that reaction. So if we look at the reaction of water, or the production of water, where we combine hydrogen plus oxygen to create our H2O. Whenever we balance this chemical reaction, we have a 2 to 1 to 2 ratio. So we have 2 moles of our hydrogen are going to react with 1 mole of oxygen to produce 2 moles of water. So those are our molar quantities. To perform stoichiometric conversions, this diagram represents the overall way to convert between two different substances in a chemical reaction. The A that's represented in this type of conversion will be the start or the original substance. So the original substance will be considered our A. And then what we want to go to, what we want to end up at in the chemical reaction will be our substance B. So if we're ever trying to convert, we have to be able to identify the unit that we're given and the unit that we need to go to, and then we need to figure out if we're going to the same substance or to a different substance. Again, stoichiometry is the comparison of multiple substances in a chemical reaction. So we have to go from one chemical formula to the next. So just to kind of review, if we ever are converting between moles and grams of the same substance, so that means grams of oxygen to moles of oxygen, we're going to be using molar mass as the conversion factor. So that's based on the chemical formula. So oxygen is O with a subscript of 2 because it's a naturally existing diatomic. And then we have to find out the mass based on the periodic table. So that's converting between mass and moles of the same substance. So now what we just learned or just talked about is the conversion between mole amounts, so your molar quantities of different substances. We're going to be using this mole ratio to compare them. And again, those are identified by the coefficients of a balanced chemical reaction. So we can have multiple types of conversions here, and we're going to start off with the most simple type of conversion, and that is first starting between moles of the first substance to moles of the second substance. So we're first going to talk about our one-step conversions. Okay, and again, mole-to-mole conversion, we have to use the mole ratio. Then if you look at the top section on the left side, if we're comparing grams of A to moles of A, we'll be using molar mass. Same thing with moles of B to grams of B, we'll be using our molar mass. So we have to be able to know where we're at and where we're going to. So our first type of problem, this is a mole-to-mole conversion. These are the one-step problems, or the one-step calculations. The question is asking us how many moles of ammonia, which is NH3, are produced when 2.5 moles of nitrogen are consumed. So we have to first write down our given. For any math problem, we identify the given. So going and writing that down, which is let me erase that. So we have 2.5 moles of nitrogen. Again, nitrogen is a naturally existing diatomic. We draw our conversion bracket because this is a conversion factor, a multimole relationship. So then I bring moles of nitrogen, come straight down to the bottom, just like normal dimensional analysis. So moles of nitrogen comes down, and we have to calculate the moles of ammonia. So I have moles of NH3. What's important here is writing in the substance within that conversion bracket, because that's going to be very, very, very important. Otherwise, we might get lost. So where do I get the numbers that go in this mole conversion bracket? We look at the balanced chemical reaction. There's an understood coefficient of 1 in front of the nitrogen, so 1 goes on the bottom. That's the number 1. And then the moles of ammonia produced in that chemical reaction is a coefficient of 2. So the 2 and 1 come from that balanced equation. And yes, we should have double checked first to make sure that everything is completely balanced. Okay, so once we put in our conversion bracket, I'm at moles of ammonia. Now I'll multiply everything across. 2.5 times 2, that is 5 over 1, which you end up with 5.0 moles of NH3. Okay. The second question is asking us how many moles of hydrogen are used if 1.50 moles of ammonia are produced. Okay, so 1.50 moles of ammonia was our given. We write down our conversion bracket. Moles of ammonia come straight down to the bottom. And this time we're calculating moles of hydrogen. So a mole of your H2 goes on top. Again, refer back to your balanced chemical reaction to determine the coefficients. So the coefficient in front of NH3 is still the 2. The coefficient in front of our hydrogen is a 3. So moles of NH3 cancel out. Now we just perform our math. 1.50 times 3 is equal to 4.5, and then 4.5 divided by 2, we end up with 2.25 moles of our hydrogen. And again, make sure you look at sig figs and units. Our next type of conversion will be a mass to mole relationship. And this is going to be mass of one substance A to another substance B. So this is a mass to mole or mole to mass type calculation. The first problem is asking us to calculate how many moles of ammonia are produced when 5.0 grams of hydrogen are used. So we write down our given, which should be 5.0 grams of hydrogen. So our first bracket, we have to make sure we convert our grams of our first substance to moles using the molar mass, because we can't change the substance or compare substances until we get to the unit of mole. So when in doubt, convert anything that you're given to the mole if you're relating more than one substance together. So grams of H2 go straight down to the bottom. Molar mass is the grams in 1 mole. So there are 2 hydrogens, each with a mass of 1, so the total mass is 2. So grams of hydrogen cancel out. Now I'm left with moles of hydrogen. So, oh yay, now I can do my mole to mole conversion, where moles of H2 come straight down to the bottom, and now I'm going to calculate moles of ammonia, which is NH3, and I get the mole to mole conversion from the coefficients of the balanced chemical reaction. So the coefficient of our hydrogen is a 3, the coefficient of the ammonia is the 2, so now I just perform my math. So 5 times 1 times 2 is 10. All over, we get 2 times 3 is 6. 10 divided by 6, you get about 1.666 repeating, and we need to round that to 2 sig figs, so it should end up being 1.7 moles of NH3. Okay, the second problem, this is going from the other way, moles to grams. Everyone needs to scratch out that grams and put moles. So this time we're calculating the grams of nitrogen that's used if we have 15.0 moles of ammonia that are produced. So my original given is 15.0 moles of NH3. Okay, so I'm already at the mole, so I'm just going to go ahead and do my mole to mole ratio, where moles of NH3 come straight down the bottom. Then I'm going to go to moles of nitrogen, because that's where I am needing to go. And then I look for the coefficients in the balanced chemical reaction. So the coefficient of 2 is front of ammonia. Nitrogen has a coefficient of 1. Now I just, now I need to do my gram, mole to gram conversion. So moles of NH3 cancels out, and I'm left with moles of my nitrogen. So then moles of N2 come straight down, and I can easily convert from moles of one substance to grams of the same substance using molar mass. So the grams in 1 mole of nitrogen, there are 2 nitrogens in a naturally occurring nitrogen substance. So 2 times 14 would be the mass of 28. So then I multiply 15 times 1 times 28, which equals 420, all over 2 times 1, which is 2. And then taking 420, divide that by 2, you get 210. I'm going to put a decimal for sig figs, and you get grams of N2. So our last type of conversion is a mass of A to mass of B. So this is a mass to mass conversion, which is a 3-step. So we need 3 different brackets here. So the first thing that we need to do is identify our given. So in this question, how many grams of ammonia are produced when 10 grams of hydrogen are consumed? We write it down, our given. So we have 10 grams of hydrogen. Before I can compare different reactants together, I have to get grams of hydrogen to moles. So grams of hydrogen come straight down. I can easily convert that to 1 mole using our molar mass. There are 2 grams of H2 in 1 mole. So the grams of H2 cancel out. That should be a G, not a 5. Then moles of H2 is going to come straight down to the bottom. And then I'm comparing hydrogen to ammonia. So I need to do a mole to mole conversion to change that substance in the calculation. So we look at the coefficients in a balanced chemical reaction. The coefficient in front of hydrogen is a 3. The coefficient in front of ammonia is a 2. And then our moles of H2 cancel out. I'm left with moles of NH3, but now I have to calculate grams. So moles of NH3 can easily be converted back to grams of NH3 using the molar mass, and that's grams per 1 mole. So 1 nitrogen plus 3 hydrogens, that's 14, 15, 16, 17. Now I just perform my math. So everything on top you multiply. So 10 times 1 times 2 times 17, you get about 340. Over 2 times 3 times 1, which is 6. Dividing that, you get about 56.666 repeating. And so rounding that to 3 sig figs because of our given, we end up with the answer 56.7 grams of NH3. So your gram to gram relationship is going all the way across from one side to the other. So stoichiometric conversions are all based on a balanced chemical reaction. So the first thing that we have to always do is make sure our equation is balanced. And if it's not, we have to go back and add coefficients to make sure that everything is equal, because we have to abide by that law of conservation of mass. The second thing we have to do is identify what we're given and what we want to go to, or what's wanted. So we can either be given grams or moles, and then we should be able to calculate moles or grams of a different substance. If they ask you to calculate the grams or moles of the same substance, that's only a molar mass conversion, so that is a 1-step type bracket. If it's a stoichiometric calculation, you have to go through the mole ratio of a balanced chemical equation, because that's relating 2 different substances to each other. And the second thing is identifying how many steps that we need in our calculation. If we just have a mole to mole conversion, then that's just going to be a 1-step type problem, where all we have to do is convert moles of A into moles of B. So that's going to be a 1-step. Our second step, or 2-step equation, is going from grams to moles. So we need to go from grams of A to moles of B, or we can start with moles of B and go back to grams of A. It doesn't matter, you can start at either or. That's our 2-step bracket. And then our 3rd-step bracket is going all the way from grams of one substance to grams of another substance. And again, you can go back and forth from reactants to products. Everything is based on dimensional analysis, so we're going to be setting up our bracket system. So it's that big line in the middle, and it can be up to 3 different brackets. So again, going between moles and mass of the same substance. That's just a molar mass conversion. And then if we're comparing the two substances, we have to make sure we are in the mole unit. And then again, if you want to go to the mass of a different substance, that's just a molar mass type bracket. So two types of brackets, it's either molar mass or mole ratios. And again, we have to be absolutely sure of what we're being given in the problem and what we're being asked to calculate. All right, so have you accomplished these objectives? If not, please return back to the main screen, rewatch the video. Please have these notes written down, or at least the problems, so that way I can work those calculations in class with you whenever we go over this lecture.